Okay, so wrapping up section 3.1, and this also kind of bridges us into the next section and what we're going to be looking at in 3.4 is something called the fundamental counting principle. And basically, what the fundamental counting principle says is if you have multiple things occurring, either together or in sequence, like this happens and then this happens, you can count the number of outcomes for those things happening together by taking the number of outcomes for each one individually and multiplying those values together. All right, so in the example that I pulled here from your textbook, they took the experiment and broke it down using a tree diagram, which is what we have done up to this point to look at the possible outcomes when you have multiple things occurring together. So in this case, we're choosing a manufacturer, and so you can see in the tree diagram, they let that be level 1, right? 3 choices there. A car size, so that was branched off in level 2, and then a color was branched off in level 3. And so looking at the tree diagram here and counting the outcomes across the bottom, right, we can see that there are 24 total outcomes. But the fundamental counting principle gives us a shortcut to where if we just want to know how many outcomes there are, not actually list them out in a sample space, right, but just get the total, then what we can do is we can just look at the number of ways that each one occurs, right? Basically the number of possibilities for each of those. And then the fundamental counting principle says the total number of outcomes can be found by just multiplying those things together. And so you can see here, if I did that, right, just multiply the number of outcomes for each one, then it would give me the exact same thing that I saw in my tree diagram, but much more quickly than having to list everything out. Okay, so you can use that anytime you have multiple things occurring together. So, like with our 3 coins, you could do 2 outcomes, right, heads or tails, for each of 3 coins, 2 times 2 times 2, and that would tell you right off the bat that you've got 8 outcomes, which again we saw in our sample space. Or the example where we had 3 survey responses and 4 geographic locations. You could take the 3 for the response, the 4 for the location, multiply, and that would tell you right up front there are 12 possible outcomes, which again, we saw in our sample space. Now, this is commonly used when you have experiments with a really large number of outcomes, where it's not practical to sit down and try to make a tree diagram or list out all of the options, okay? And again, it's used anytime we want to look at a situation where we have multiple things happening, and we want to know how many possibilities there are. So here we're customizing a laptop, and we have 5 different things to be considered. So you'll notice what I did down here is I just laid out each thing that I need to look at. And then what I'm going to do is go through and just list the number of outcomes for each one. Okay, so the processor has 3 possibilities. The graphics card has 3 as well. 4 choices for memory, 6 for the hard drive, and 2 for the battery. And what the fundamental counting principle says is once you look at the number of outcomes for each individual, you can pull those together by just multiplying, and that would tell me there are 432 possible outcomes. This method is also very commonly used when you want to look at like possible combinations of letters and numbers. Like if you want to know the number of possible license plates, right? You could look at 3 letters, 3 numbers. If you want to look at the number of possible passwords or usernames, or in this case, we're looking at an access code. Because again, what you do in the fundamental counting principle is you break it down in terms of each item that has to be assigned. So here, right, the first thing I was told was that the access code consisted of 6 digits. So notice the blanks that I laid out here, right, are just where I'm going to assign each piece. What's digit 1, digit 2, digit 3, and so on. And then when I go to assign each digit, what I want to remember is that there are 10 possible digits, right? That's how many we have to choose from, right? Because a digit can be 0, 1, 2, 3, 4, all the way up to 9. That gives me 10 possibilities. So without any other restrictions, right, what I would do is I would say, well, each one of these digits has 10 possible outcomes because it can be anything from 0 to 9. All right, and if there were no other restrictions, I would just multiply, and that would give me my total number of outcomes. Now, if there are restrictions, I can just go back now and adjust for that. All right, this says the first digit cannot be 0. So I'm going to come over here to digit 1, and I'm going to say, all right, that means that digit 1 doesn't have 10 possibilities. It only has 9 possibilities because it can't be 0. Right? Do the same thing for any other restrictions. The last digit must be even. All right? So I'm just going to come down here and note even digits would be 0, 2, 4, 6, or 8. All right? That means if this digit must be even, there's not 10 possible digits. There's only 5 because it has to be 0, 2, 4, 6, or 8. And then once I've accounted for any restrictions that I need to, then the fundamental counting principle says multiply these together, and that will give you your total number of outcomes. So 9 times 5 is 45. I'm going to have 4 zeros there, and that's going to tell me there would be 450,000 possible outcomes for a 6-digit access code with the restrictions given.